In this part of the lecture, I will talk about variables and constants. We start out with the variables. You can see a variable as a container in which you can store values. You give the variable a name, which you can later use to reference the variable if you, for instance, want to retrieve the previously stored value. As you can see here, we store the value 42 in a variable named val. We can later retrieve that value. And notice that val keeps its value after we have retrieved it. This seems easy enough, but why do we use variables? Let's look at an example. If we take the Pythagorean theorem, c equals the square root of a squared plus b squared. In this example, a is 3 and b is 4. If we do the calculations right, we see that c is 5. If we then change the values of a and b, now a is 7 and b is 12. We see that the values change, but the equation that we use is the same. If we use variables, we don't have to change the code in the equation, only the values of the variables. And this is a big gain, especially if we have a complicated equation. Then we reduce the risk of making mistakes when rewriting the code. In addition to this, if we have many triangles that we need to calculate, we only need to change the values of the variables to do the next computation. You will see the strength of this later on when you learn about loops. Here we have a variable named x. In this line of code, we assign the value 15 to x. The equal sign here is used as an assignment operator. It's not the same as an equal sign in mathematics. Here, the assignment operator tells the interpreter to assign the value 15 to x. The name of the variable has to be on the left-hand side. Then the assignment operator in the middle, followed by the value to be assigned on the right side. There are different types of variables which have different properties. Some of the basic data types are integers, floating point values, strings, which are text, and Boolean values, which can take the values true or false. Here we see a few examples of assignments. The first example is the assignment we saw earlier. We assign 15 to x. 15 is an integer, a whole number. In the second assignment, we see an example of floating point assignment, or a float. In the third line, we see the use of an expression on the right-hand side of the assignment operator. When you have an expression on the right-hand side, the expression is first evaluated, and then the value, in this case 10, is assigned to x. In the following line, we have the assignment of a short text, a string. And the last assignment is perhaps the most interesting one. Here you can see the value 12 enclosed in single quotation marks being assigned to x. Any value enclosed in single or double quotation marks is a string, even if it's a number. So this is also an example of string assignment. You can assign the value of a variable to another variable. Here you see y getting assigned the value 12. And in the next line of code, you can see x being assigned the value of y. And as y has the value 12, you now assign 12 to x. You can also change the value of a variable. Here we first assign 42 to var1. Then we assign a new value to it, 21. After that assignment, the 42 can't be recovered again. It's been completely overwritten. You can also use the same variable on both sides of the assignment operator. Here we have x is assigned the value of x plus 1. The expression on the right-hand side of the assignment is evaluated first. Here, x has its initial value of 4. 1 is added to 4. The sum is then assigned to x. after this line of code, x has its new value, 5. Now I'm going to talk about how you should name your variables. And this is actually more important than it sounds. By choosing good names for your variables, your code will be much easier to read and understand. Both others and future you will thank yourself for choosing well. So choose descriptive names. Let the name of the variable tell the reader of the code what it contains. If you want to store the air temperature and ground temperature, call the variables air temp and ground temp, and not things like temp1 and temp2. A variable name has to start with a letter or an underscore. Following characters can be letters, numbers, or underscore. So 0.5 is a valid name, but 5 point is not. Variable names are case sensitive. Air temp with a lowercase a and t and air temp with an uppercase a and t are two different variables. But you should never use case sensitivity to separate two variables, as there's too big a risk you will mix them up. There are two styles of writing the names of variables. A lowercase letter in the start of the first word, and then uppercase letters for the leading letters in the following words. This is called camel case. The other style is called snake case. In this style, you use all lowercase letters and separate the words with underscore. Python, of course, recommends snake case. You can use any of the two styles, but be consistent. Only use one style in a script. There are a number of keywords in Python that have special meaning. These keywords are reserved and cannot be used as variable names. For instance, is a keyword. This means it can't be used as a name in your script. It can, however, be a part of one. For listing is a valid variable name. Now we come to the constants. There are some values that never change. For this, we have the constant. Here I've taken a few examples. It's math.pi, math.e, which is a natural logarithm, and math.inf, which is an infinitely large number. If you, for instance, need to use pi in a script, you should always use the constant math.pi to avoid any errors. That was the end of this part of the lecture.